Result of testing the hypothesis and then developing an explanation that is believed to be true. And a model is an example of how something reacts in relation to the theory.
Okay, awesome. Anybody else wants to give it a go? Anybody else has a different answer? Or something along the same line? Anyone? Anyone? So, I read my answer. Your answer is correct, by the way, very much so. A hypothesis is a tentative explanation based on data collected up to a point when the hypothesis is developed. So it's a research statement, like you said. Yeah. An example is the idea that burning fossil fuel is causing global warming. Okay. A coherent set of hypotheses forms a theory. Okay. A theory is supported by a substantial body of data and has survived repeated challenges. For example, the theory of plate tectonics. Okay. And a scientific model is based on many hypotheses and theories and is a precise representation of how a natural process operates or how a natural system behaves. For example, a computer model of Earth's geodynamics. Okay. Anyone knows what a geodynamo is? Okay, we'll come to that later. Question number 2. Give 2 reasons why Earth's shape is not a perfect sphere. 1. Yes, you.
Rotation.
Rotation? So what happens?
Yeah, because of the rotation, the mountains at the equator and its partial.
Yeah, so because of the rotation, the Earth is at the equator. Okay? So the distance, if you look at from the center of the Earth to the equator, and from the center of the Earth to the North Pole, there's a 12 kilometer distance. Okay? So at the equator, it's 12 kilometers longer than at the North Pole. Okay? And that's why it's not a perfect sphere. What is another reason that it's not a perfect sphere? You answer? Yeah. So perfect sphere is smooth, but as we know it, the Earth is made up of a lot of mountain ranges as well. So the Earth has a topographic relief. Of half of the Earth's living species, including all dinosaurs. Does this event disprove the principle of uniformitarianism? Explain it. It's a mouthful. It's hard to pronounce. Uniformitarianism. What is that?
What happened in the past happens continues in the future and all that.
Yep. So whatever is happening now is the key to the past. Okay. So what's happening in the present? You can assume used to happen in the past as well and vice versa. So that is uniformitarianism. So does that large meteorite impact 65 million years ago caused the extinction of dinosaurs and almost half the species of our planet? Does it disprove the theory? No. Because these are all isolated incidents as well. Okay. How did the large meteorite impact cause the extinction? What did it do? It does. One word answers. Exactly what I'm looking for. Do you care to elaborate?
aluminum dust.
Anybody? Yeah, that's okay. Anybody else willing to give it a try? Something more. Something more.
Well, the dust blocked out the sun.
Yeah. So it produced a lot of dust, which went to the atmosphere. It blocked out the sun. What happened next? What happens if the sun is blocked out for a few years? What will happen? It will go dark, and then what will happen? All the plants will die first. Who will die next? Which type of animal? All the herbivores, because there is no more plants. Once the herbivores die out, then the carnivores will come. How does the chemical composition of the Earth's crust differ from that of its mantle and then from that of its core? What is the crust made up of? Like elements like what? And
Silicon and oxygen.
what is the mantle made up of? Okay. Any particular element you have in mind? Okay. Silicates. Okay, but which silicates? Silicates are compound. I'm sort of looking at elements. Magnesium and iron. And what is the mantle made up of? Iron and nickel. So what happens is, as you go from the surface into the core, you get progressively heavier and denser elements. Okay? So during the early differentiation of the Earth, when I say differentiation, I mean when it developed its different layers, the crust, the mantle, and the core. That was during the time when it is theorized that the Earth was a liquid ball of fire. So I'll use another example that I used in the last class. What will happen if you take up a handful of soil and throw it into a bucket of water? It will sink to the bottom. Okay. But does the whole thing all sink at the same time? No. It is the heavier, larger materials that will sink first, and then you have this progressive layering of fine elements going up. So that is something that you can compare to the early differentiation of the Earth as well. So when it is a liquid ball of fire, the heavier materials of the elements will go to the center, right? And then you have progressively light elements falling upwards. Therefore, the crust of the Earth is lighter than the mantle, and the mantle is lighter than the core. Okay? Number 5. Explain how the outer core can be liquid and the inner core solid. Yes, you. No. Somebody else willing to give it a try? Pressures? Yes. What about pressure?
That press, I think that's enough.
Keeps it solid. So yeah. And the outer core is under low enough pressure to keep it liquid. Remember, melting temperature is one of the most important factors that determine the temperatures of melting for elements is also the pressure that they are at. So if you are taking, for example, iron here at 1 atmospheric pressure, For example, the temperature of melting may be 120 degrees Celsius. But if you take it into the metal, it is subjected to very high pressures. Okay? So the melting temperature will change. The melting temperature will be high. So the melting temperatures of elements are subject to the pressures that it is subject to. Okay? So in the outer core, the pressures are low enough to keep the iron and nickel liquid. But as you progress into the inner core, the pressure is increasing because of what? Why is the pressure increasing as you go down? Not because of gravity, but because of the weight above, right? If you're scuba diving, if you're diving into the ocean, as you go further down, the pressure increases because of the weight of the water column above. Same as you go into the interior. Anyway, if you have an increasing amount of weight on top of you, the pressure increases. It's a function of weight is a function of pressure as well. Okay? So because as you go further down, the pressure increases, therefore the melting temperature also differs. 6. How do terms weather and climate differ, and express the relationship between weather and climate using examples from history. What is weather? You. Weather is a bit confusing. Anyone wants to help? Anyone willing to help? Okay. Yes. Anyone else has a slightly different answer? So the weather refers to the atmospheric variables, like what? Yeah? What else? Okay, look at today's weather. What are the variables that you're looking at? You have winds, you have cloud cover, you have a temperature. So these are all the atmospheric variables for a particular place and time. That is weather. But if you're looking at climate, you're looking at these atmospheric variables over a long period of time. Okay, say a decade or so. And that will define your climate. So, what are the climatic conditions of here? Generally, yes. But if you look at the climatic conditions of the western side, as opposed to here in Suba, what is it? It is generally wetter here and it is dry on the other side. Okay, number 7, Earth's mantle is a solid. Yeah, but it undergoes convection as part of the plate tectonic system. Explain why these statements are not contradictory. Okay, what is convection? Flow. So, you have convection cells. So if you heat anything up, what happens when you heat something? Yes. What happens to density when you heat? Okay, when you heat something, does it expand or contract? It expands. And what happens to the density when something expands? It increases. Because now there is more space between atoms, so between particles. Yeah? Because it is expanding, the density decreases. If the density decreases, what will happen? Okay, if you're looking at water, what will happen? If you heat something, will it go up or down? Up. Because density decreases. Yeah? Density decreases, volume increases. Okay? And once if something cools down, what happens? Atoms come closer together, density increases and it sinks. So that is what happens in the metal as well. Because the inner core or the core itself is the hottest, yeah, because of the temperature is there, it's the hottest, it heats up the metal. Okay? So when the metal material heats up, as it comes closer to surface, it starts to cool down because it's further away from the heat source. And once it cools down, it starts to sink again. So this is what you end up with. So that is the convection cell, and that is what is one of the main driving forces behind plate tectonics. So if you have this cell that is rising and then going that way, that means the plates above it will move that way. And this is at a mid-oceanic ridge. So that's the mental convection cell. Yeah? So convection current, as I would say. And that's the driving force behind plate tectonics. Okay, so this is mostly related to liquid things. But the mantle of the earth is solid. How does convection work in solid material?
Be changes in mineral bonds in terms of heat and pressure.
Yes.
The tenfold on the pressure.
Yeah. On the line, somewhere along the line. Okay. When it, sorry. Yes. Because it is subjected to heat and pressure, the solid rock is ductile, and when it is ductile, it behaves as a plastic. So it experiences internal flow. Internal flow, mineral by mineral flow. On an atomic level, like you said. It experiences internal flow. So that internal flow, obviously it will be extremely slow. And that is why the plate movement is in the range of a few inches per year. Yeah? So, next one. Anyone knows the construction of the earth? No? The next question is, imagine you are a tour guide on a journey from Earth's surface to its center. How would you describe the material that your tour group encounters on the way down? And why is the density of the material always increasing as you go deeper? We just discussed that. Why is the density always increasing? Because of increasing pressure. Increasing pressure brings the particles or the atoms closer together, therefore the density is increasing. Okay, so if you are supposed to go from the surface to the center, what are the different materials you will encounter first? And what is the densities of these? And how much of these would you encounter? And for example, if you go from the continental crust what would be the difference of that compared to going from the oceanic crust? There's a difference. Continental crust is made up of which elements? Mostly. Aluminum, oxygen, silicon, right? These are light elements. Oceanic crust, however, is made up of iron and magnesium as its major elements. So these are oceanic crust are basaltic, yes, and basaltic. Therefore, it is denser than the what? Continental crust. Okay. Huh?
Continental crust, calcium.
Continental crust is calcium because it is granitic. Okay. So you have rocks which go from basic, intermediate to calcium or acidic. Some would say it's acidic. So basic rocks are basalts, intermediate rocks are andesites, calcium rocks are rhyolites. These are exclusive rocks. And then there is a inclusive equivalence to exclusive rocks. I'm getting off topic here. But the continental crust is much thicker compared to the oceanic crust, because oceanic crust is very new crust. Okay? What is the thickness approximately in a range? What range of thickness would you give to continental crust?
Crust is 7 to 10.
More or less like 20 to 50. That would be a range. Not an exact thickness because it differs in every place. And what would be an average thickness of the oceanic crust?
7 to 10.
Yeah, 7 kilometers? Yes. Okay, so when you're answering this question, you go through first, if you're going through the continental crust, you pass through 20 to 50 kilometers of the continental lithosphere, which is less dense, okay, compared to oceanic lithosphere, which is more dense. Okay? And then when you reach the metal, what happens? The mantle 2 is divided into a few parts, or two major parts, the upper mantle and the lower mantle. The upper mantle is called the stenosphere, which is about how thick?
20.
No, it's about 300 kilometers. That's the stenosphere we're talking about. Once we pass through the stenosphere, we go into the lower mantle, right? And how thick is this? Or 2,600, because we taking 300 as the stenosphere, so not 2,900. Okay, 300 is the stenosphere, which is the upper mantle. Collectively, it's 2,900. Okay, so what are the materials that you encounter? As you progressively go from the upper mantle down to the lower mantle, up to the core mantle boundary, what will happen? The materials that you encounter are progressively more dense, isn't it? Yeah? And then, after this, 2,600 kilometers of lower mantle, we will go to the outer core. And what is the outer core made up of? Huh? Iron and nickel. Liquid, iron and nickel. And how thick is this? 2,250. Yeah. And that is liquid, iron and nickel. After that, you go into the inner core, which is how thick? 1,220. And this is what is the state of the inner core? Solid. And then when you start coming out the other side. That is the same sequence of materials that you encounter. Okay. Some people make a mistake and think that the metal is liquid. Don't make a mistake. It is solid. Only very small pockets are liquids or semi-molten, and these are places mostly where the plates are subducting. So the oceanic crust is subducting. Okay? And as it is subducting, because the oceanic crust has been exposed to hydrated minerals, or it's been exposed to water, the minerals get hydrated. Okay? And as it plunges down into the mantle, it is carrying all this water with it. Now there's two main functions of water. Okay? One, it reduces the melting temperature. Okay? And two, it redistributes heat evenly. So as it is plunging down into the mantle, the crystals or the minerals that are holding this water gets dehydrated. So the water gets released. And as the water gets released, these melting temperatures decrease and the material starts to melt. Remember, it's already solid there at a certain pressure. Okay? With higher pressure, the temperature of melting increases. Okay? So if it remains at the same pressure, but because of the water, the melting temperature will decrease. And therefore the material in the metal starts to melt, which is why it is called partial melting. So the plate that is subducting does not melt completely. Okay? These incompatible elements are the elements that come out of this melt first. So the light rare elements, heavy rare elements, generally the rare elements, they come out first because they are incompatible elements. Okay? So at these places, you're producing melt material or metal. Clear so far? Okay. So we'll move on to the next question. Okay. Number 2. How does viewing Earth as a system of interacting components help us to understand our planet? Give an example of an interaction between two or more geosystems. Who wants to answer that? Anyone? Start volunteering or I start taking? Us to understand our planet. Can you study Earth as a whole system, or it would be easier to study smaller systems and how they interact with each other to understand the planet? Smaller systems. Yeah? So we divide the Earth system into smaller components, understand how each of those components work first, and then how these two components or three components or whatever, it works together. How do they interact? So in doing so, understanding smaller parts of the Earth system, you are able to understand the bigger picture. Yeah? So if we are looking at Earth, we have three main systems. These are the now that's the atmospheric system that we're looking at. So that's the climate system, the plate tectonic system, and the geodynamic system. So climate system exists there, right? Plate tectonic system exists there, and then the geodynamo exists there. So if you're going from top to bottom, so you have the climate, the plate, and then the geodynamic. What does the geodynamo system do? It produces the magnetic field. Yeah? And how does that work? How does it produce the magnetic field? First, what does the geodynamo consist of? The core. So the solid inner core and the liquid outer core. These two components make up the geodynamo system. And one of the main functions of the geodynamo system is to produce the magnetic field. And how does it do that? Not exactly convection, but to some extent, yes. So remember, this is liquid. How do you produce electricity? You have a magnet and you have a coil of what? Basic science, remember? Okay. In a similar fashion, not exactly the same, you have the flow of liquid out of core going around the solid inner core. And that produces that interaction produces a magnetic field. And what does the magnetic field do? From solar radiation as well. Otherwise, if we had no magnetic field, what would happen? What would solar radiation do to us? Not exactly. Okay, so that brings us to the next question. In what general ways are the climate system, the plate tectonic system, and the geodynamo familiar? And in what ways are they different? How are they familiar? They all interact with each other for the functioning of the planet as a whole. And how are they different? Different parts. So they relate to different parts of the Earth. Okay. Climate system exists on top, above the crust. Plate tectonic is the crust and the upper mantle, and the geodynamo is the core, the inner core and the outer core. Okay. Not every planet has a geodynamo. Why not? Why does every planet not have a geodynamo? In order for geodynamo to exist, we just discussed we need a liquid outer core and a solid inner core. And what are the prerequisites or the conditions that produce such a liquid outer core and an inner core? Pressure. And what is linked to pressure? And okay, say what happens when you dive down into the ocean? The pressure increases because of the weight on top, isn't it? Okay. So in order for geodynamo to exist, you need a planet to be of a certain size, so that it can have low enough pressure to keep a liquid outer core and a high enough pressure to have a solid inner core. If you have a planet which is too small, smaller than Earth, what will happen? there's not enough pressure from the top. Not enough weight pressure for that particular gear dynamo to exist. Does it make sense? Yeah? What must it also have in addition to the pressure? High concentration of what? Iron and nickel. Let's say, theoretically, well, in theory, moon is part of the Earth, right? Which formed by a meteorite impact millions of years ago during the early formation of the Earth. So, say if Earth has already differentiated, okay? Differentiated meaning it had formed the different layers. And the meteorite only hit the, for example, only hit the crustal layer. So that the moon would be made up of what material? The lighter elements, iron, silicon and aluminum. Would then the moon have a geodynamo system? No, because there is very low concentrations of iron and lithium for one, and it's also very small. Yeah? Oh, we just discussed the second part of that question. If air did not have a magnetic field, what might be different about the planet? Okay, it also, what would be different is the rocks would not be magnetized. Magnetic susceptibility and or magnetic orientation is one of the main ways in which we can sort of age date our rocks as well. So if you're looking at the oceanic crust going from the mid-oceanic ridges, okay. Now these iron and magnesium, these iron minerals are magnetic minerals, right? And that has a magnetic field. So when at mid-oceanic ridges, lava comes to the surface, and as it solidifies, because it has this magnetic minerals inside, it will orientate itself to the magnetic field. And we also know that the magnetic field keeps on changing every time. Okay? So over millions of years, the North Pole becomes the South Pole, and the South Pole becomes the North Pole. Any idea? Anyone has any idea what is our current magnetic declination here in Fiji? Approximately 12.3 degrees to the east. I'll answer it or we'll wait for you. Okay. So as this lava is erupting, the magnetic field is registered with these magnetic minerals. Okay. So if you're looking at, if you look at the oceanic crust and you measure magnetic orientation, this is what you look at. Say for example that is the ridge, mid-ocean ridge. You'll have strips. So north orientation, south orientation. North orientation, for example, south orientation. And this is what you get when you're looking at the magnetic orientation of the oceanic crust going from the mid-ocean regions. Because that is preserving